Today, I'm going to walk you through creating a game that has real feeling physics in Python. We'll be doing this through a rocket landing simulation where the objective of the game will be to land as softly as possible. This is going to be a beginner-friendly video for anyone learning to code their games or anyone just interested in physics and real implementations of it. I know this because 3 years ago I was a beginner myself, and after lots of practice and multiple projects, I finally broke through that beginner phase of programming, and I'm here to help you gain that same confidence. So without further ado, let's get into coding the simulation. So to create the whole interface and the 2D animations and pictures, I'm going to be using the Pygame library. So import Pygame. It's the easiest way to create like a visual in Python. And to actually use Pygame, we have to first initialize the library. So pygame.init. And this is basically like starting the engine of a car. And so then let's actually create the screen. So I'm going to create variables for the coordinates, like the size of the screen. So I'll do screen width, or width, and the screen, and the S stands for the screen. And I'll set that equal to 1000, and the screen height, and that I'll set that equal to 500. I want the screen to be wider than it is tall. And then we need to create the screen object in Pygame. So screen equals pygame.display, and then we need to create the actual window, so set mode, and then we pass in the coordinates, the size as a coordinate, so s width, comma s height. So this is basically our canvas for everything we're gonna do on Pygame. And then I'm gonna come down here and I'm gonna create a variable called run, and I'll set this equal to true. So this is basically the variable like in which our game loop will run, because all games need a game loop for refreshing the screen and checking for inputs and stuff like that. So while run, which is set to true at the beginning, what we want to do is we want to do pygame.display.update, and this will update the screen, because without that it's not really a game or a simulation. And then we also want to control how often our screen updates, basically like our refresh rate, so how many times our game will update in 1 second. So to do that, we need to create a clock object, and that will be equal to pygame.time.clock. And then down here we can do clock.tick, and then we pass in our frame rate, and I'll do 60, I guess. And so now we basically have like the framework of our game ready, and now we can actually get into making the game itself. To do that, I'm gonna come down here and I'm gonna create a class, and I'll call it the rocket. And we want this to be a sprite class. This is because we want to be able to use special features Pygame gives us in its library for sprites. So to do that, I'm gonna pass in pygame.sprite with capital S, and we inherit all the functionalities from this. And then we need to actually initialize the instance, so def init self, and then to actually inherit from the Pygame sprite library, we need to do super dot init. And so for all sprites, we need 2 attributes minimum for it to actually work and show up on screen. We need an attribute called image and an attribute called rect. We first need to import in the images that we're going to be using. So what I'll do is I'll create a attribute called self.rocket image, and I have an image that I want, a custom image that I want to use for this rocket. So to load in that image into the program, we have to run pygame.image.load, and then in here you pass in the relative path to your game. For me, it's that, and I also want to add 2 other images, and this is basically going to help with the animation of the thrusters and the flame at the bottom of the rocket. So self.flame1 is equal to pygame.image.load, and then I'll pass this in, and then I'll also do self.flame2 and pygame.image.load, and I'll pass in this as well and change this to 4. And then finally, to smoothen the transition of it downloading the files and showing it up on screen, we're going to run .convert alpha. This basically helps the game run more smoothly and faster with these images. It converts it to an easier file type for Pygame to use. And then to switch and alternate between the 2 flame images, I'm going to create a list that contains the 2, self.thrust list, and this will be self.flame1 and self.flame2. And I'm also going to create an index variable, so self.image index, and I'll set it equal to 0 to now. We're going to be using this variable to alternate between the 2 flame images to create our animation. And then finally, we actually need to create the image and rect attributes. So self.image, and it has to be named image. And I'll set it equal to self.rocketImage for now, because that's the starting image. And the rect attribute, which is going to be self.rect, again has to be called rect. And I'll set it equal to self.image.getRect. And I'm also going to give it coordinates, so I want it to start at the bottom middle of the screen. So mid bottom is equal to get the middle of the screen, I'm going to do s width divided by 2, and to have it be at the bottom of the screen, oh no, never mind, I want it to start at the top of the screen because it's falling and we want it to land. That's my bad. And to do that, we need it to be 0. We start at 0 at the top of the window because in Pygame the Y value increases as you go down. And to finish the images off, we're going to come down here. To show the flame images, we need to know when the thruster is actually on. So we'll create a self.thruster attribute, and we'll set it equal to false at the beginning. And then let's create a method for this class. I'll call it defAnimation, and we'll pass in self. And what we'll do is if self.thruster, which if it's true, this condition will be true. We want to change the image index value, so we'll do self.image_index, and we'll change it by 0.1 for now. And this will help us like alternate between the 2. And so what we want to do once we have the image index value, we want to do self.image is equal to self.thrust list and self.image index. And we also want to make sure this is inside integers, because the index of the list has to be an integer, and this int function will round up whatever the value is to the nearest integer. And we also want to make sure that this doesn't go above the length. This doesn't go above 1, which is the length of the thrust list. So what we'll do is if the integer value of self.image index is greater than len of self.thrust list, what we'll do is we'll set self.image index back to 0. And if the thruster is not on, else we'll do self.image is equal to self.rocketImage. And so to actually be able to see the animation on screen, because right now if we run the program, that's not a good idea. Oh, and I also did forget, while we were setting up the display and stuff, we also need to set up how we're going to actually exit out of the program, because it's very important to do that when you have a while loop, because you don't want to try to close the program but then this while loop is still running it messes up with your computer. So to do that, we're going to need to check for the event in which the program is closed. So we'll do for event in pygame.event.get. We want to do this in the game loop because we want to check every time the game updates. Pygame.event.get is a list of events that happen at that moment in time, and we want to iterate through each of those items. And if event.type is pygame.quit, make sure it's in all caps and no parentheses. We want to do pygame.quit with parentheses this time because it's a function, and run equals false. This way it closes out of Pygame and it ends the while loop. And now to actually see this animation that we did earlier on screen, let's create another method and we'll call it def movement. And in here we'll have the input controls of the player into the game or the simulator. And what we'll do is we'll turn on the thruster every time the player presses the spacebar. So in order to do that, we first need a list of the inputs that happen at the moment this function or this method is called. So we'll create a variable called keys, and we'll assign it to pygame.key.getPressed. And so what this will do is this contains any keys that's pressed at that moment in time that's currently pressed. And if keys contains brackets, square brackets, pygame.k_space, we'll do self.thrust. Oh, we need to first pass in self.thruster equals true, spelled true right, by the way. And we'll create one more method because instead of doing first animation then movement all separately in the game loop, we'll create one method. We'll call it def update. We'll pass in self, and what we'll do in here is we'll do self.animation, and we'll also do self.movement. So this way both of these methods are run in this update method. And before we can actually put these in the game loop, we need to actually create our instance of the class and create our sprite. So what we'll do is down here we'll create a group for the sprite, and we'll do pygame.sprite.group single because there's only one, and I'll call this rocket will be an instance of the rocket class, and we'll do player.add rocket. So now we've created our instance, and down here we can do player.update as well as player.draw, so we can actually see it on the screen. And up here we also need to give the screen a background color, so I'll do screen.fill, and I'll give it this color. Alright, so now let's try running the program. Oh, there's an error. And in this draw method, we also need to pass in the surface we want the player to draw on. And I just thought of one more problem, that right now we can't even see the rocket on screen because where we've spawned it in, it's outside of the window borders. So for now, let's put it into the middle of the screen. So we'll do s height divided by 2 here in the self.rect when we assign self.rect. So now if we run the program, there it is. Oh, and we ran into another error. Alright, so it says the list index here when we create the self.image while the animation is going on, the list index is out of range. However, here, I'm pretty sure I assign it back to 0. So here's what we'll do. We'll print self.image index to see what the index is when, or we'll print it up here actually. We'll print it up here before an error occurs so we can see what causes the error. Alright, let's run the program. Okay, so let's scroll up here. Oh, here we can see it actually goes over 1. Oh, and that is because this len method, the length of the list is actually 2. So I'll subtract 1 to account for the 0 index that's at the beginning. So now if we run this program, it should work fine. Yup. Oh, but it doesn't stop. The animation doesn't stop when we let go of the spacebar. Oh, and that's a very simple fix. Here we did if a spacebar is pressed, we set self.thruster to true, but we never set it back to false. So we'll just do else if spacebar is not pressed. We'll do self.thruster and we'll set it equal to false. Alright, let's try running this. Yup. The animation is working just fine. Now we can get into the actual physics of this program or of this simulation. And so before we get into equations and all that fun stuff, let's assign some attributes and variables. For example, we'll first do gravity, and that's equal to 9.81, and the units is meters per second squared. Then we'll also set some attributes for the rocket. We'll do self.mass, and we'll say this is 1,000 kilograms, because that's the SI unit for mass. We'll also do self.max thrust. We need to know how much power this rocket is capable of outputting, and I'll go with 20,000 for now, approximately 20 times the mass. And we also need to know the throttle, which is the amount of thrust being used. So we'll do self.throttle, and we'll set it equal to 0. Oh, and by the way, this is in newtons. And we'll set this equal to 0 for now. Self.max throttle, and we'll set it equal to 1. So this throttle will be a percentage of the total max thrust that the rocket is using. And we'll also do self.acceleration. We'll set that equal to 0. The units for that is meters per second squared, and self.velocity is meters per second, or hash is 0, and that's meters per second. Alright, so now if we go into the movement function, or movement method, we can actually start working on the physics and gravity and the other fun stuff. So first, let's calculate how much force the rocket is putting into the ground vertically, which is, we'll call the thrust force. That's the amount of force the rocket is generating. That will be self.throttle, which is the percentage of the total throttle, times self.max thrust. So that will give us the amount of thrust force. And then we have to calculate the net force, which is the total force being outputted or affected onto the rocket. This is going to be combining gravity with the amount of force the rocket's producing. So this is going to be equal to thrust force minus, and this will be gravity times self.mass. And so this is the amount of force being acted on the rocket. Now let's move on to the acceleration. We'll use a very famous equation called F equals ma. but we're gonna tweak it a little bit, and we're from F equals ma, we derive A equals F over m, which is acceleration equals force divided by mass. So self.acceleration is equal to the net force divided by self.mass. And then for the velocity, we also need to account in for the time, because acceleration and velocity are very time dependent variables. So down here, every time we run this method, it happens 60 times in 1 second. So we need to know how much time that is for each singular run of the method. So what we'll do is we'll come up here at the top of the while run loop. We're gonna set a delta time variable, which is the change in time, so the amount of time in which this loop or this iteration of this loop happens, and we'll set it equal to clock.tick, and it's 60 for us, and we divide that by 1000, and so this will give us the time in which this method will run. So if we come back up here, we're going to assign the self.velocity variable, and we'll do plus equals self.acceleration times delta time. And this works because if we look at the units, self.acceleration is meters over second squared. So now we have to multiply that by a second, by the seconds unit, which we get here through delta time, and that gives us velocity, which is just meters per second. Now we also have to account for the drag that the ship experiences. This is to slow down the ship when it starts falling, so it doesn't just keep accelerating up for an extended period of time. So we'll do if not self.thruster. So this is basically when the throttle is not on. So what we want to do is we want to set drag. This will be our variable to slow down the ship. Drag will set equal to 0.15, and we also need to factor this into the actual velocity itself. And we're going to do this by multiplying self.velocity by 1 minus the drag. And I'm not going to go into too much detail on why this is the case. Oh, it's minus equals. I'm not going to go into too much detail on why this is the case. This is kind of out of the scope of this video, and it's some complex physics, but what we need to know is that it makes the animation look smoother, and it makes the physics feel more real in the game. And then finally, all of this is done in the meter unit. However, our screen isn't really scaled to that, so we need to change it to pixel velocity, and this kind of just depends on like everyone's different screen and size. And so I'm gonna do pixel velocity equals self.velocity, and I'll start with 4 right now. And finally, to actually change the position of the rocket, self.rect.y minus equals pixel velocity, and we want to make sure it doesn't go there, that there's a ground. So if self.rect.bottom, the bottom of the rectangle of our image, of our rocket image, is greater than, and I'm not going to put the screen height here. What I'm going to do is, because in my PNG file, the rocket itself isn't actually at the bottom of the PNG file. That bottom section is used for the fire and flames coming out of the boosters. That's approximately 40 pixels. So I'll do s height plus 40. And if this is the case, I'll set self.rect.bottom back to s height plus 40. Alright, and now let's actually get the controls so we can actually use the boosters. So up here, when we check for when we turn on the thruster, what we'll do is we'll also increase self.throttle, and we also want to include our time variable into this. So let's say we want to increase it by around 0.03% or 3% every second. We need to calculate how much that is according to our refresh rate. And so we know that down here when we calculate the delta time, clock.tick60 divided by 1000 is 0.0167 seconds. So if we pull up the calculator, 2% is 0.02, or no, 3% is 0.03, and if we divide that by 0.0167, we get 1.8, which I'm gonna round to 2, so 2 times dt, so this will delta time, so this will increase our throttle by 3% for every second that our spacebar is pressed down. And we also want our throttle to decrease when our spacebar is not pressed down. And we want the throttle to decrease a little bit faster than it increases, because it's easier in like real machines and real rockets to decrease faster than increase the speed. So we'll do self.throttle minus equals, and I'll do 3. I'm not going to do too much calculations for this one because it doesn't really matter all that much, and delta time. Okay, so now if we try running this program, we will see if our physics is working. And when I press the spacebar, it goes straight down, and then after some time it goes back up. And I think I know why that's happening. And this is because when we press the spacebar, the throttle turns on, but it's at a very low number at the beginning, so it doesn't exactly help in bringing up the rocket. So I think what would help is creating like a minimum amount of throttle, so the rocket will be able to propel itself upward at the beginning instead of it taking so long. And so we can actually see all of it happening on screen, and it looks a bit more realistic and it's more fun to play with. So to do that, we'll come up here. When we turn on the throttle, what we want to do is, before we change the actual throttle value, we'll set a minimum, and I'll do 0.5. So if self.throttle is less than 0.5, we'll do self.throttle equals 0.5. And that's our minimum throttle. So now if we try running the program, and there's our game basically working. And I do want to do one more thing on the actual screen. I want to be able to actually see the information about velocity, acceleration. And so to do that, we first have to come up here, and we need to create a font for our actual text. So I'll create a variable called font, and I'll set it equal to pygame.font, and this time capital F font. And you can enter a font file, but for now I'm just going to use the default Pygame font by doing none, and the size can be 20. So now if we come down here, in the movement function, we can add our text. So first we need to create a surface variable, a surface object for our text. And let's do velocity first. I'm going to call it vel, and it'll be equal to font.render. This will create our surface, and we need to pass in the text we'll use. So I'm going to do velocity colon, and I'll concatenate it with a string of the self.velocity value. And then this boolean value doesn't really mean much, and then the color, I'll have it be white. Then I need to create the rect object as well. So we'll do vel underscore rect, and this will be vel.getRect, and I'll set the top left coordinate to 0, 50, so it's at the top leftish of the screen. And finally, I want to actually put it on the screen, So screen.blit. This is the function used to add surfaces onto the actual screen on the Pygame. And what we'll do is we have to pass in the surface, which for us is vel, and the rect value vel underscore rect. And now we have to do the same thing for acceleration as well. So I'm just going to copy and paste, come down here, and change this vel to ACC, I guess. ACC. Change this velocity to acceleration, and this to self.acceleration. And finally in the split section, ACC and ACC. Alright, that looks good. And last thing I want to do is also add the Y coordinates so we know how far above the screen it is. Alright, so now we should be able to see all this information on the screen. Oh, but it's all in the same place, and I forgot to change the coordinates. So I'll just increase it by like 30 each time, 80, and then 110. Alright, now let's try running this. And there's also the information. We can see the, oh, we have two, I forgot to change the text of this one. Coordinate. Alright. There it is. And we can see the Y coordinate getting more negative as the spaceship gets higher. And as it falls down, Y coordinate gets closer. Oh, and there it is. Now let's work on the actual game aspect, which is the how hard it's hitting the floor. So for that, we're going to create a new method, and we'll call it def collision, and we'll pass in self. And so what we want to check is if self.rect.bottom equals s height plus 40, the Y coordinate at which the actual ship part of the image touches the bottom of this window. And we want to check if the velocity is too high or too, and we'll do if self.velocity is less than -1. That means if it's falling too fast. What we want to do is we want to return loss. And else we're gonna return when, and we're gonna call this down here. So result rocket dot collision, and if result equals loss, then we'll run equals false, and in the terminal we'll print lose or loss. And we'll do the same thing for win. If result equals win, what we'll do is run equals false and print win. Okay, so now if we run this program, we fell too hard and it's loss. Now let's fall like a bit slower, and we still lost the bottom, so see, and it's win this time. So yeah, that's our game working, and we use this using, a lot of simple Pygame and physics concepts. If you want to see a more complex Pygame project where we use more complex sprite classes, collisions, and we involve time heavily, and we have a full score system and health system, then watch this video next. See ya!